The first procedure we're going to do is to identify what are transverse waves. The first one we're going to do is straighten the rope and place it above a long table. Next one is we're going to hold one end, which is this end of the rope, and vibrate it up and down. With this, we can observe a pulse. So we must draw 3 sketches of the rope showing the motion of the pulse at 3 subsequent instances, or snapshots at 3 different times, or draw an arrow to represent the direction of the pulse. Now we will tag a specific part of the rope while making a series of pulses. The series of pulses is also considered as the periodic wave because one pulse follows another in regular succession. Now we will tie one end of the rope in a rigid and fixed object, which is the table stand. Now we will attach this colored ribbon on one part of the rope, which is this part, and we're going to use adhesive tape to fix the ribbon. Now that we attach the adhesive tape to the ribbon, we must make a wave by continuously vibrating the end of the rope with quick up and down movement. So we just do it just like this. And as you can see, the waveform of the shape of the wave that was formed was up and down as I am moving the rope up and down. And you can also conclude that the ribbon is not moving towards the end because it only follows the movement of the wave. As well observed in the experiment, the wave did not transport the colored ribbon from its original position to the end of the rope because as the wave moves, the colored ribbon also follow its movement. So we can answer this question. So we can answer this question by saying that the wave didn't transport the colored ribbon. So the wave did not transport the colored ribbon.
Activity 3. What are longitudinal waves? In this activity, we're going to identify on what are longitudinal waves and what does it look like.
Connect one end along the table wall. So, here.
I hold nga.
And
Basa.
then, pause.
Basa.
Okay. Place the coil spring on the top of the table. Attach one end to the coil to the wall while you hold the other end. Do not lift the coil spring. Vibrate the end of the coil while the spring is doing back and forth motion of the length of the spring. So, naon. Then, stop. Observe the waves along the coil spring. Draw what the coil spring looks like as you move it back and forth. So, this is what the coil spring look like when you move it back and forth. It looks like this. Attach the colored ribbon from one part of the coil spring. You may use adhesive tape to fix the ribbon. Vibrate the coil spring. Alright, so dikit sana to.
Division asa. Ito sa basa.
Alright. Then, spring back forth while you observe the motion of the regular ribbon. Remember. Back and forth. Remember that the colored ribbon serve as a marker of the chosen segment of the coil spring. So, mauni siya ang marker sa coil spring. Yeah.
Does the waves transport the colored ribbon from its original position to the end of the spring?
No, because the coiled ribbon is following the movement of the wave. So meaning ang ribbon wala siya gaano sa coil. Ang coil lang iyang ginasundan. Yeah.
How did the colored ribbon move as waves pass by?
Okay, the colored ribbon only follows the movements of the disturbance or wave caused by the ripples. So, nag-move ning coil because sa mga ripples. So, balik sa imong force na pag-ana, nag-move po ang coil. So, yeah, that's it.
In activity 3, we're going to identify on what are surface waves. The first thing we're going to do is to place the basin filled with water on top of a level table. So, which is what we're doing right now. And we're just going to wait until the water becomes still or motionless. And we've done waiting, so the water is now still or motionless. The next thing we're going to do is to create a wave by tapping the surface of the water with your index finger and observe the direction of the direction of travel of the wave pulse. And we're going to do a continuously amount of waves that's also called as periodic waves. So we're going to use our index finger. We're going to do this. So as we can see now, this is what we call periodic waves, the continuous motion of waves. So as we did this, we must view it from the above, and we must draw it. We must do the pattern that we see in the box. So in drawing, we must draw the basin. So as we did tap our index finger in the water, which is the pulse, it forms a wave around in its surroundings, and as waves form, as one ripple, we're going to hit the other side of the basin. Another ripple will form, and if that ripple again, we're going to hit another side of the basin. Another ripple will form, and that scenario is called periodic waves. Pause.
Now that the water is motionless, we're going to put here some paper boat. But since we don't have a paper boat, we use the empty matchbox. Yes. So as you can see, we're going to create periodical waves with my index finger. Wait lang, steady sa ang boat. So 1, 2, 3. As you can see, the matchbox was not moving. It was moved by the waves. That's it. Thank you.
Do the waves set the paper boat into motion?
It only moves to the means of the waves, but not the direction of the waves.
What is required to set an object into motion?
An object needs a force in order to move. If you exert more energy in creating periodical waves by tapping the surface with greater strength, how does this affect the movement of the paper boat?
Yes, it does affect the movement of the paper boat. In slight tapping of the water surface, the paper boat or the matchbox will not move, but with greater energy and great force of tapping, the matchbox will also move due to the increasing amount of the energy used in tapping the water, creating a pulse. As shown in the image, the passage of a wave across the surface of a body of water involves the motion of particles following a different pattern about their original positions.